Lines of Charge, Lab 2. So the purpose of this lab was to use the data from the previous lab to create a better model of the electric force on the tapes using a line charge instead of a point charge. The model is 2 pieces of tape that was charged in the same method, with one tape below the second tape. The physics principles involved in this lab are the electric charge properties, Coulomb's law, and the equation for the force of charge, which I wrote below, which is kq1 times q2 over d squared. And all of this we're using so that we could set the electric force equal to the force from gravity in order to figure out what the charge on the tape is to balance out the top tape so that it won't move, meaning that the force is 0. So the main result that I got from this lab was that the charge on one tape was 3.9 times 10 to the negative 8 coulombs. So here's my model. The system is tape B and the surroundings is the Earth, which creates gravity, and tape A. The initial conditions are listed below, with the main thing is that only gravity acts on tape B initially, and when tape A is placed underneath tape B, the electric force causes tape B to move up. So here's my code. In the first section, you can see I wrote the mass down and Q. And the main thing in this lab was that I kept editing Q, and I used guess and check in order for the electric force equal to the gravitational force. You can see it's still slightly off, but it's close enough that it's about even. Over here is just my E field, and I just used the equation for the E field, and then wrote down all the R mag and R hat, and returned the E field using those variables. Over here, this just creates the top tape line charge and the bottom tape line charge. You can see the bottom tape is at the origin and the top tape is 0.05 above it. Here's just the scalings I used so that the arrows would show up properly on the screen. And over here is the iteration for the green arrows to create the E field of the tapes. Over here is the FE arrow and the FG arrow. So the FE arrow is used using the scaling that I used and the force electric on top, and then the FG arrow is just negative mg in the y hat direction. So I had to keep editing Q in order for those two to equal each other again, as you can see here, and I got 3.9 times e to the negative 8 as the charge on one piece of tape. So, like I said, the charge on one piece of tape was 3.9 times 10 to the negative 8 coulombs, and I used guess and check to find the charge. We assumed that gravity and tape A were the only forces acting on tape B, so we excluded air resistance. And in this lab, we assumed that each tape had the same net charge and said that the tape was a line of charges rather than a point charge centered at the origin of the tape. So some sources of error was that tape A or B could have lost some charge while we were handling them, which would have caused our distance measurement to not be as accurate. And because that was not precisely measured, the new Q that we found using this lab is different from the Q that we found in the last lab. So if we modeled each of our tapes as a single point charge in the previous lab, the charge would be significantly different because the line charge is distributed across the tape and would be more accurate than the point charge. In the last lab, I calculated the charge to be 4.667 times 10 to the negative 9 coulombs, and in this lab, the code created the charge 3.9 times 10 to the negative 8 coulombs. So you can see that there's a significant difference between the two. And the reason that they differ is because the charges in the tape may not be perfectly uniformly distributed, which can cause differences in charge across the tape, so treating the tape as a line charge would be more accurate than a point charge. Thank you for listening.